welcome back, Generals, to another Let's Fix Generals 0 to make the best game ever. Good. Last session we started to decoupling particle update from Brenda, from Logic, from Logic step. So let's see how we do that. So we have update the wind motion. That is okay. Let's go on here. Position, last position. Okay. I think that's fine. Yeah. Attach to driver ID. Yeah. Blah blah blah. Okay. Attach to object ID. Okay. Is shrouded. Okay. Get shroud status. Okay. Okay. Draw. Okay, this seems to be all fine to me. Okay, but here we have a transform. What is this? World space, okay. Okay, this seems to be fine. Blah, blah. Okay, what do we have here? Controlled by particles, position, okay. Okay. I think this is fine as well. Okay, what do we have here? Generate new particles. Generate this particle. Actually create a particle. Okay, I don't see anything here. Okay, update all particles in the system. Gravity. Apply gravity force. So plus equal. Okay, so this is to me this looks like we can time scale, yeah. Okay. Delete instance. Okay. Okay, and then here we have an update. So we need to look into that then, and I think that's it. Okay, let's go to updates. Okay, so here it's getting interesting. Acceleration. Plus equal velocity times acceleration. Acceleration. See acceleration decreasing. Oh, it is accumulation next frame. Okay, who's setting this? Apply force update. Okay. Okay. apply force. Okay. Okay, it's not so much, but it's a little bit lifetime. Okay, we need a reel here. If lifetime is larger than that, and lifetime minus time scale. Should probably do a real time scale here. Time scale. Unsigned int. Time left is the max 0. X for int. Okay. Update timescale. Now apply force. Do we have a get on this? No. I would say we don't multiply it here, but we multiply it in here. Yeah. to larger giraffe. Yeah. Smaller equal. Let's do. Let's write this a little bit nicer. So we do that, and then we do. If lifetime left is smaller equal that. Okay. So here the acceleration is reset. Okay. Accumulation next frame. It's weird because it only ever applies the same force, right? Like there's nothing. There's no other force here. Yeah. So I think what we need to do here is const real xl. Yeah. Nah. Time scale. Well damping times equals well damping. Well damping. Well damping. Let me ask ChatGPT if we have something, if we have some update logic like the following, and we want to if we have some update logic like the, let's say if we have some fixed update step like the following, and we want to have a free update for a render loop and scale the damping, then scale, if you have a fixed update step like the following, I want to have a unconstrained update render loop and scale the damping for each render frame. Then how the mass look like that, because it's not like we can't multiply by time scale here. We need to somehow think about it. We need to think about this. I was just recently thinking about this, but I already forgot it. If we I'm not sure. Let's just ask. Let's see what it comes up with. Fixed step exponential decay. Yeah, converting to a variable render time step. Factor. Power. Fill damping. Is that right? Pow. Fill damping dt divided by fixed dt. Yeah, that's what I do have a time scale value which where 0.5 means I do have a time scale value where 0.5 means halved speed and 2 means doubled speed. Time scale dt delta time times time scale factor. What? Factor. Well damping scale dt divided by fixed dt. Is that right? Factor damping scaled dt divided by fixed dt. How many fixed simulation steps worth of time past this frame? Delta time times time scale fixed dt. I don't think we need that, or do we? Damping per second. Okay, I'm a bit confused by this here. I didn't expect there to be a delta time and a fixed delta time. I would have thought I'd just work with the time scale. Delta time, yeah. Okay. Is there a way we can calculate it without the delta time? Delta time and fixed delta time? No. Time based. It's true, yeah. True. This one inherently contains time. Right. True. True. Okay, that's fair. Okay. What about this one here? Fixed dt. Yeah. Scale dt. So we'd have a real, would have the frame pace, get update time, right? Time scale. Then we have damping. Okay. The fixed dt is logic frames. Logic frames per second real, right? This one. Seconds per logic frame. So scale dt, frame pace, time scale. Let's add another argument here, real frame time. How about we call it render time? Mm-hmm. Mm-hmm. Then we take this and do. Mm-hmm. What would be a good term for the steps? Step. I call it render step. Okay. Then that would be multiplied in the end. Mm-hmm. Okay. I hope that will work. Yeah. Mm-hmm. Mm-hmm. Here we have time scale. Let's call this render time. Get update time. Okay, render time, render step, damping, step, okay. Render step, okay. Then here we have drift well and well, drift well, velocity into position. Let me ask. Okay. But for edits, for edit values, we can simply scale by time scale, right? For edits or subtracted, whereas you can simply scale by time scale. Delta time. Huh? At a fixed amount of velocity per frame. Yes. Yeah. Frame rate dependent physics. But the but it already contains, I don't know, I would have expected that this is correct. Why do we need to Excel? No, dt times dt. Timescale is the difference between render, update, and logic step. So at 60 FPS, render FPS, with timescale 0.5, it would represent logic timescale over FPS ratio. So difference. Timescale would represent logic step at 30 FPS. Already scales. Yeah. Damping is a per step fraction, so it needs exponentiation. Less damping, more damping. Timescale already encodes that ratio, so no extra math is needed. Okay, great. So we can just pass timescale to our exponents. Okay, fantastic. Then let's do that. Then we don't need render time anymore. Let's put that here. And remove that. And remove that. Okay. Damping. Okay. Let's call it veil damping. Okay. Okay, great. Good. Then here we also do timescale. Wind motion. Okay, do wind motion. Wind motion. Yeah. Then here we also need a real time scale. Okay, position, blah, 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 object, and then plus equals time scale. This is the post drop. Okay, hold on. Be offset by that position as well. Okay, I'm actually not sure that this is correct here. This is not something that we scale. So the object position. Let's leave that alone. Okay, but here we have something. Dist from wind. Dist from wind. Here, wind. Here we scale this one. Yeah, time scale. There we go. Okay, I think that's it. Time scale. Okay, great. Angular rates. Okay, so this one we also need to scale. No. Damping. Okay, here we have this shit again. Then here we do angular damping. Okay. Angle Z. What is this? Angle between? Adjust the up position. Okay. This one is fine. Okay, we have size rates. So this one we also scale, and this one as well, the damping. Size rate damping. Okay. Okay. Alpha rate. Okay, alpha rate. Times time scale. Max frames. Oof. Oof. Okay, this one is tricky here. Need to revisit that. Let's put a note here. Danger. Okay, here we have a clamp. Okay, update color. This one is straightforward. Here we have another danger zone. Danger. Okay. Resync this. Time scale. Okay. Time left. Okay. Okay, that's not too bad. So we only have these two things left here. Well, and maybe what's inside this one here. Alpha rate. Something going on here. Compute alpha rate. Alpha rate. Hmm. Hmm. I don't know. Okay, so I mean, we could cast this to integer alpha key frame. What is an alpha key? Eight. Okay. Okay. Who's using the alpha rate? Here, okay. I see, I see, I see. Okay, fair enough. Okay, smaller. Okay. So I think we need to turn this into a real as well. Then here we cast it to integer. Unsigned int. Let's do unsigned int of a target index. Then here we do plus equal timescale. And then that would be it. And here we do color target index. So we have this and that, okay. And then timescale. Okay, does that make sense? Oh, we have more here. Compute alpha rates. Okay. Oh boy. Oh boy. Hmm. Mm-hmm. Int x for int equals that. Okay. X for int, okay. Okay. Unsigned int. Color target index. This one is alpha target K. Index. Okay. Color target index. Okay, fantastic. I probably made some mistake somewhere there. For target key, that one is correct. Unsigned int. Color. Yeah, okay. Color target key. Yeah, okay, that one is also correct. Okay. Okay, so far so good. Was quite a bit, yeah. Let's see if it compiles. Update. Particle update. Update. Yeah. Okay, drift velocity. What is this? Drift velocity. Angular damping. Okay, as far as I can tell, this looks correct. Maybe. For strength. Hold on, this time scale is wrong. Needs to be here. Because this is conditional. Okay. Okay. Yeah. Okay. Let's see. Let's see. Fails. Okay. Aha. Okay. Okay, fair enough. There we go. Okay, now let's see if this looks any good. No. Okay. So, let's see. Okay, that looks promising, but the particles look a bit large, don't they? I think the speed looks okay, but they are so fast, so big. Something is not right. The particles are outrageously large. Why is that? It looks already pretty good. Yeah. The explosions seem to have the right sizes. But there's some issues there. Yeah. Yeah. Maybe the explosions are a bit too large, aren't they? Yeah. The bullet effects on the tanks also look too big. The water particles, they spread too far away. It's not right. Something is wrong. Something about size. Size and, I don't know, distance. Okay, so we need to look again in the update. Something is still wrong. Updates. Velocity. What about vel itself? Let me ask ChatGPT. In the following function, I added a bunch of time scale modifiers, but it does not look quite right. What could be wrong? Let's see. I can see why it doesn't look quite right. Defined as per logic step for the surrender frame. Correct in principle, but only if well damping is a fraction per full logic step. It is. It is. If your logic step is already 160 and timescale is smaller, this works. But if your damping was tuned for a per frame update, defined per logic step, it is. Scaling additive updates with time scale alone is only correct if your values are already per logic step. They are. If your acceleration drift angular rates are defined as per second, you should multiply by dt. They are not. This common source of particles feeling sluggish. And seconds. Lifetime left. No, this should be correct. What is this? Copy paste errors. Oh. Oh, it does. It does, yeah. Classic. Simulation for green blue. Where? Full velocity. Okay, I don't think that the AI is on the right track here. Let's think about this. I mean, it looks close, right? So like the speed, it looks like the let me open a game. Actually, it's already they are too big. They are definitely too big. Like they're gigantic. Yeah. Okay. So it's like something about the size, the growth, something about the velocity. Let's think about this position. Velocity. Aha, we are not scaling the velocity here. Is that a problem? Well, damping. Drift well. Okay. Drift velocity. Right down. Apply time scale. Okay. I think there's something wrong here. Take a look at the size rate. Where's that here? Size rate, size rate, size rate. Let me check size rate. To me, the size rate looks okay here. I'm not sure. I think we will get there. I just don't see the error right now. To me, it looks like we have something is wrong here, because the velocity is never scaled, right? Like this thing is scaled, and the dampening is scaled, but this one is not. But at which step should it be scaled? Maybe here? Let's think about this. Okay. Maybe we need to do here like this. And this. Could that be? Let's see how that looks. I don't think that will fix the size issue, but maybe it will fix the distance issue. Yeah. Okay. Let's see. Okay, that doesn't look too bad. Oh, it looks pretty decent. Ah, well, we are at 30 FPS. Never mind. Okay, let's observe. Okay, I can already tell it's not looking right. The particles are way too large. Yeah. Yeah. The velocity looks okay now here on the boat. Yeah. The bombardments here also look okay to me. Yeah. Let's look at the test map. So let's build some things. The light ball looks way too large, doesn't it? It shouldn't be this large. Something is wrong with the size. Yeah. Can we... how about we do the following? We launch the original game and we look at it side by side. So, generals. This one. So this is the original game. Yeah. Then let's set it to 30 FPS here. No. And then we take this. And let's load into missions. Actually, let's compare the shell map. How about that? Let's just observe the shell maps. We need to change the render FPS. Let's change it to 90. Okay. So it's around about the same. Okay. Let's see. Okay, explosions look similar, I would say. Can we get it more in line with each other? Let's see. Speed it up, so catch up. Okay, now they're roundabout identical. A bit more. Okay, they're pretty close now, right? So let's take a look. Unfortunately, the screen is not large enough to see both games. Okay, but it should be good enough. Okay, it looks very similar. I would say the cannons look pretty much the same, yeah. The beach. To me, it looks like there are more particles spawning on the beach, which is probably not intended. Yeah. It's hard to tell if it's really the same or not. Because there's just so much happening right now on the screen. Let's look at the Gatling cannon, Gatling tank. So they have to me it looks like the red light of the Gatling tanks, it's somehow more pronounced looking on the right side. Yeah. Okay, let's load into a mission. Maybe that will be more revealing. So. Yeah. So. Okay, let's get some Humvees here. Okay. Okay. Then here, let's set it to 30 FPS and let's shoot. And so we can see that the light is much smaller on the Humvee. Let's zoom in a little bit. This one is much, much bigger. Yeah. Okay, so there's certainly something wrong with the light here. Let's zoom in a little bit. Let's shoot here, yeah. Okay, so the explosion looks very, very similar, right? This also looks similar. Yeah, okay, so it looks very similar here. But this light is a very obvious difference. Why? Is that maybe because of the clampings? So there were a bunch of clampings here, right? So updates. Let's do a timescale search. Current documents. It looks very close already, but there are still discrepancies. So we need to figure out where that comes from. So there's something here. Computer, how much you will change the angle? There's a minimum change here. I wonder if that plays any role. But this one is for wind motion. I don't think that plays a role here. Position. Let's look at the scale again. Size. Size rate. Color target key 1. Curious why it starts at 1 and not at 0. Huh. It looks cute. Yeah. It looks cute, but it's not right. We want it to look the same. Also, it looks like the light on the ground is not quite right. I like the bullets. You can now see how smooth the bullets fly. That's pretty cool. Yeah, I like that. Looks really smooth now. Okay. Right now I have no idea why this is happening. So we do scale the acceleration, we scale the damping, we scale this thing here, in motion, the angular rate, yeah. Yeah. And then emitter deer. Yeah, okay. We update the size. Update alpha. Let's say we lower the frame rates. Why is this happening? Could it be that there's just more particles being spawned? Because the lifetime is 0 or something? Or like the burst time is 0? Maybe? Yeah. I have a suspicion. I have a suspicion here. Yeah. I have a suspicion. I think so. There was this code in somewhere in one of these updates, right? It's, for the burst or something, right? Here, the burst delay. What if the burst delay? What if this one is 0? So on every render update, it will create a new instance. Yeah. Yeah. Uh-huh. I think it's related to that. so that it creates more particle instances, because the burst is set to 0. And so every single render frame, it will create a new particle, and they stack on top, and then it creates this big bulb of lights, because it's just like multiple now. It's not just one small, or just one, but it's like many stacked on top. I think that's what's happening here. So maybe, so burst delay originally was unsigned float, right? And zero emitter particle burst. Particle burst. Yeah. How do we solve this? I think here, I think here we need to say max. So std max 1.0f. So at most 1, because that's like what the original did. Max. Yeah. Okay, let's test that. Yeah. Skirmish. Let's see if that theory is right. God damn, I'm good. Look at that. Fixed, bitches. God damn, I'm good. Yeah, that fixed it. Look at that. Oh, that's fantastic. Okay, cool. What about the muzzle flash? Why don't we see that? Here we see it. Huh. Well, it is there, but it's hard to see. Okay. Okay, so the burst delay was indeed responsible for this. Fantastic. Okay, that's cool. Then what else can we look at? Let's get a toxin tractor. Toxin tractor does a lot of particles. Okay. So the render frame rate is uncapped. Logic is at 30. That looks good to me. Cool. Let's do the sprayer. It's hard to see, but it looks okay. Let's get the normal one. Okay. Oh, it's also blue. Okay. Let's get the let's get a new cannon. Oh, those are so slow. Okay, let's get. We can't. Oh, we need a propaganda. Let's get the dragon tank and all the others. Get a lot of units all stuck here. Okay, let's see the dragon tank. Okay, that looks very, very good. God damn, that looks good. Holy shit. Nice. Looks pretty solid. Cool. Oh, this doesn't look right. This looks too big here. Something is wrong there. Yeah, so something is wrong here. This doesn't look correct. Let me compare that here with this one. Oh. Let's get the nuke one. Yeah. So this is the original game. Oh, it actually also looks big. Huh. Okay. Is it the same or not? Huh, they both look big, but this one looks a bit bigger. Looks very similar. It looks a bit bigger to me. Yeah. This also looks a bit different here, right? Something is a bit different, but what could that be? Hmm. Maybe move them down also to the darker terrain here, so that the comparison is closer. The light looks very similar here, this one, right? Looks very similar. Explosion. To me, it looks like this explosion has more volume. This one looks a bit more nerfed, right? Looks a bit smaller. Like, these guys don't have as much volume as they do. Maybe there are more particle instances still. Okay, let's zoom in here. Can we pause it? So this is about the same position, right? If we look at these guys. The rocket is here. Here's this trail light. And this one certainly looks much more intense. I have the suspicion that here are two particles instead of just one. Here's one and here are two. Maybe. What did we touch? Lifetime left, yeah. First delay left, delay left. What does delay left do? Delay left. First delay left, delay left. Aha. So there we have another of these guys, delay lefts. What is that? Delay left. Delay left. Initial delay. I don't think that this has any influence. But what about the start timestamp? There's something we missed here. It looks really like that there's one too many particles here. It looks bigger. But what could it be? Burst delay. Delay left. Timestamp. Create timestamp. What about this one? Okay, here we still have a discrepancy. This doesn't look right. What does it? No, I think that is fine. Yeah, that is fine. This is fine. Yeah. What could be the problem here? There's something sneaky. Let's look at the burst delay again. Burst delay. Burst delay. Time between particle emissions. Burst delay. There's one thing that could explain it. If we have half, wait, hold on. But it was integer before. It was integer before. Who is assigning this? What are we assigning here? Burst delay, get value. So this one is a float. I have a suspicion here. So if we look at this one, whoa, why do we have color coding here now? If we look at this guy, we search for burst delay. Oh, color coding is all different. Right. So this one uses float values and it uses halves as well. Then I think that one is responsible. Yeah. Then I think what we need to do is let's do if preserve retail behavior, else, and if so burst delay was originally unsigned int. Okay. So preserve retail behavior. So I think what we need to do is unsigned int burst delay. Otherwise we use real burst delay. Burst delay. There we go. Let's make it const as well. And then here we use burst delay. Original used. Yeah, let's add a comment later. And then here we say, let's do real unsigned int real. Okay. The original code used integer burst delay. Integer-based burst delay with reduced preserve it, preserve that to keep it to preserve the original look of particles. Let's say keep base personate with the original look of particles. Okay, let's try that. I have good hopes, high hopes that this fixes the issue. Yeah. No, I could be wrong, of course, but I can't think of anything else right now. If it's not that, then we need to think harder. But to me, this seems logical. Yeah. Maybe there are more of such cases where we need to clamp round back to integer and lose the precision. Yeah. Let's get those tank counters again. Let's get a China one here. Okay. Let's oh boy. Okay. That's still big. It's not that. It's still big. Sure. I don't know. There must be something else. Yeah. Well, we can also clamp the other guys if we find more. Maybe burst delay is not the only one responsible. So we have lifetime. Yeah. We have all sorts of guys here. Yeah, we probably need to do it with all of them. The same thing. Yeah. Okay, but I think I will end it here. Yeah. Yeah, I'll end it here. Has been almost 2 hours. Yeah, I think it was a good session. We made good progress. Then I wish you a great day or night. Until next time. Goodbye.